Welcome to part 6 of Mr. Mike's guitar build. In the last video, I forgot to include the drilling for the pitometers. Ideally, this step should be done before you hog the material out for the controls. Is it absolutely crucial? Not really. Can you do it after? Yep. But from experience, it's definitely better to do it first. In this video, we'll be drilling those holes, routing out the control cavity on the back of the body, and then we'll wrap things up with a quick review and demonstration of the spindle sander. And before you go, if you like guitar builds, woodworking, or watching someone who slowly realizes they should have read the manual, hit subscribe, drop a comment, and give the video a thumbs up. I don't need the validation, but I do appreciate it. Next, we need to drill the holes for the volume and tone controls. Doing the step early makes the layout and alignment much easier and ensures we're not fighting uneven surfaces later. The first thing I do is mark the center location for each control hole. Accuracy is important for both function and overall look of the guitar. To do that, I use an owl to make a small reference mark for each center point. These marks give the drill bit a place to start so it doesn't wander when it first contacts the wood. Before drilling, I take a moment to check that the drill bit is seated properly in the chuck and spinning straight. A bit that's not centered can cause tear out, oversized holes, and vibration, so it's worth taking a few seconds to make sure everything is running true. For this operation, there is no need to set a depth stop, because we're drilling all the way through the body. What is important though is safety. The guitar body should be securely clamped to the drill press table. I'll be honest, I skip clamping here, and it's not something I recommend. Always clamp your workpiece to keep it from shifting and keep your hands away from the bit. At this stage, we're simply drilling 4 holes for control knobs, 2 volume, 2 tone. I'm using a 3/8 drill bit here, which is the correct size and standard pitometer shafts. I drill slowly and let the bit do the work, clearing chips as needed to cut clean and prevent tear out on the backside. Taking your time here ensures clean and accurate holes that will make the final assembly much smoother later on. Once these holes are drilled, we can confidently move to the toggle switch and the control cavity, knowing the control layout is locked in and exactly where it needs to be. Next up, we're going to router out the control cavities on the back of the guitar. This is another one of those steps where accuracy really matters because everything we do here affects how the electronics fit and how clean the final guitar looks. Just like before, the first thing we need to do is set up our template. I want this template to be perfectly flush with the outside perimeter of the guitar. I'll take a second to check all the edges and make sure nothing is overhanging or shifted. If this template is off even a little bit, the cavity and the backplate won't line up, and that's not something you want to discover at final assembly. Once I'm happy with the alignment, I'll clamp everything down tight to the bench using multiple clamps here, because this piece absolutely cannot move. Any movement while routering can cause tear out, chatter, or a ruined cavity. Now we're thinking about depth. We want to router these cavities to the same depth as the holes we drilled out earlier. That leaves us with about 4 millimeters of material on the guitar face, which is exactly what we're after. That keeps the face strong while giving us enough room inside for our pots and wiring. If you don't go deep enough here, the pot shaft won't stick out far enough and you won't be able to thread on the nut, and that's a problem you don't want to fix later. Once again, this is not a one pass operation. I'm taking about a 1/4 inch off per pass, sometimes even less. Slow and steady is the name of the game here. You'll see me stopping between passes and adjusting the router depth, just gradually sneaking up on the final cut instead of forcing the bit to do too much at once. Because this is an inside cavity, the direction of travel matters. I'm moving the router in a clockwise direction, which keeps the bit pulling against the template instead of trying to run away. That gives you more control and a much cleaner cut. Another quick safety reminder while we're here, 2 hands on the router at all times, especially when you're doing internal routing like this. You want full control, and any time I need to adjust the depth, I shut off the router completely before touching anything. No shortcuts here. After the first few passes, I hit the maximum depth what the router bit will allow while the jig is in place. So at that point, I remove the jig and take the cavity just a bit deeper to finish it off. That's totally normal, depending on the bit you're using. And once that's done, you can see we've got a nice clean cavity with smooth walls and a flat bottom. With the main cavity done, we move on to routing the recess for the back plates. These are shallow grooves that let the plates sit flush with the back of the guitar instead of sticking up. The depth of these recesses is based on the thickness of your cover material, which in this case is about 2 millimeters. Above the volume cavity, we're routing out a diamond-shaped recess, and above the toggle switch area, we're doing a large circular recess. Once again, I've made these dedicated jigs for these shapes. I designed them so everything lines up properly, and so I can clamp the jig down in one place and route both recesses without having to reposition anything. The whole purpose of this groove is to make sure the plate sits flat and can be screwed down tight, clean, and professional looking. To set the router depth for this, I measure the thickness of my jig material and then the depth of the recess. In this case, the jig is 3/4 of an inch MDF, which is about 18 or 19 millimeters, plus the 2 millimeters for the plate thickness. That puts the total depth around 20 to 21 millimeters. And just like before, when we're making these cuts, 2 hands on the router, take your time and move in a clockwise direction since we're routing the inside of a template. I've already done a bit of sanding off camera at this point. And then it hit me, this is probably a step worth filming as well. Just as a refresher how to properly use a spindle sander and what we're actually trying to accomplish here. The goal with the spindle sander is to remove any machine or tool marks left behind from earlier steps. That includes marks left from the bandsaw, the router, any small chips caused from drilling, but especially the router bits when we're referencing the templates. One thing I'm noticing here are some small uneven transition along the edges. Little micro ridges and dig-ins left behind from the router bit. Nothing major, but they'll absolutely show up later if we don't deal with them now. Our goal at this stage is to get the entire perimeter of the body perfectly smooth and consistent. That said, you have to be careful. If you sit in one spot for too long on the spindle sander, you'll create a divot, and once a divot is there, sanding it out evenly can be a real pain. To avoid that, I keep the body moving at all times, and I'm always feeding it to the left. That's important. Feeding the wrong direction can cause the piece to self-feed, which means the sander can grab the body and send it flying. That's dangerous and something you definitely want to avoid. Another important thing here is don't wear gloves while using the spindle sander. Gloves reduce your ability to feel what's actually happening at the surface. Your hands are your best gauge for detecting small ridges, dips, or uneven spots as you sand. When it comes to pressure, light passes are key. Multiple light passes are always better than trying to hog material off in one go. Heavy pressure is how you end up with divots, waves, and uneven edges. After a few light passes, I stop, feel the edge, and visually inspect the surface before continuing. This is also a good time to put on a dust mask and make sure the dust collection system is running. The dust coming off this at this stage is very fine and you really don't want to be breathing it in. And just to repeat one more time, don't linger in one spot. Keep the body moving, stay patient, and let the machine do the work. This step might feel a little slow, but it pays off big time. Spending 15 to 20 minutes here will save you a ton of work during the final hand sanding stage, and it helps ensure the body feels clean, smooth, and professional before moving on to the next stage of the build. Thanks for watching. Like, comment, subscribe. Bye!